We are going to finish 3.5 today. The discontinuities homework, the one that I passed out on paper yesterday, that's due at the very beginning of class tomorrow. So please bring that with you tomorrow and you'll turn that in. You're totally fine. The 3.5 homework that's on Canvas, I went ahead and bumped that date back to being due tomorrow night. Since we're not finishing up 3.5 until today, I pushed that due date back so you guys can work on it, ask me questions tomorrow if you have questions or confusion, and then it's due tomorrow evening. Hopefully you watched the video last night that finished up the parent function stuff. If not, it's something that you will definitely need to watch in order to be able to complete the homework. We are going to talk about piecewise functions today. So a piecewise function, we have different rules for different parts of the domain. Different function rules governing different parts of the domain. So if you guys remember back last week when we were sketching those graphs where it gave us intervals like here it's increasing and then it's decreasing and then it's increasing again, and we kind of sketched that shape in, and I drew some little guidelines in on our x-axis based on those intervals. We're going to do the same kind of thing here. So we're going to draw in little fences, guidelines. These are my domain restrictions. We're going to label each side of the graph. Once I have that dividing line between these two function rules, or sometimes there will be three function rules, I'm going to determine which side of that guideline the functions live on. Then we will graph each function on its proper side. Then it says, remember to have the owner of the fence paint it. I will know which one is the owner based on who has the greater than or equal to or less than or equal to as part of the domain restriction. And by paint it, I mean we're going to do a filled in dot. If you do not have all of this copied down into your notes yet, go ahead and grab your phone and snap a picture. And then we're going to get an example up. One thing I want to warn you guys about before I put the first example up is that piecewise functions, when you first see a piecewise function, they visually look very overwhelming. It looks like a lot. We're going to talk about how to break it apart so that you know what to do with all the pieces and they don't feel so overwhelming. So here is our first example. Fair warning, it is visually overwhelming when you see this piecewise function. First thing I go looking for on a piecewise function is I'm looking for the commas. So I see a comma right here. I'm going to look at the part after it. Down on the bottom, I see a comma right here. The parts that come after the commas, these are telling me my domain restrictions, where I'm going to put the dividing line between these two functions. When I look at these domain restrictions, this one says x is less than or equal to 0. This one says x is greater than 0. So I have a dividing line between these two functions right at x is 0. So I'm going to sketch that in for myself to divide these two out. Which function, the one on the top or the one on the bottom, which one lives on the left side of the graph? The top, which it just says 3. But don't forget, this is f of x equals. So I have f of x equals 3 here. So that's the same thing as y equals 3. So which function rule lives over here on the right? Bottom one. 2x plus 1. So f of x equals 2x plus 1. Same thing as y equals 2x plus 1. Once I know where that dividing line is between my two functions, and I know which side each one lives on, now I'm going to graph them in their own spaces. This one only lives on the left, y equals 3. What does that look like? Horizontal line at a height of 3. So like this. When I actually get to this dividing line, will it be an open dot or will it be filled in? Why?
Because it's equal or less than.
Yes, we have that or equal to. So where it hits the fence. Thank you, sir. Where it hits the fence, it is going to be filled in. So far, so good? All right. What kind of a shape am I doing on the other side? 2x plus 1 is what? Is a line. It's written in slope-intercept form. Where is the y-intercept for this line? At 1. So normally I would just come over here to the y-axis and I would put my first point there and then I would use my slope. But what's the problem with what I just drew? It's a closed dot. Where this one hits the fence, it has to be open. And it's only going to extend to the right. looking at this function as a whole, I realize it's made up of two individual functions, but I'm looking at this as one full piece. What is the domain for this piecewise function? What values of x is it defined for? Yeah, negative infinity. We come over, I got a filled in dot here. I jump down to here, but it is defined at x equals 0. And then it is defined for everything to the right. Negative infinity to positive infinity for my domain. What about the range? What are all the possible y values, outputs? Yes, sir?
1 to infinity.
1 to infinity. I know around the infinity I need a parenthesis.
Parentheses around the 1 to 2.
Why?
Because it's an open circle, which means it cannot be exactly.
It cannot be exactly 1, but I can get 1.000001 as an output. That is valid. Are there any discontinuities here? Jump discontinuity. Where is the jump discontinuity happening?
0.
At x equals 0. Make sure when you're telling me about discontinuities, you tell me what kind, and you tell me where they're happening. If all you were to write is a jump at 0, that doesn't give me enough information. It's x equals 0. When we talk about our discontinuities, you want to tell me where in the domain that is happening. So the x. I'm sorry, you had a question.
Could you say jump, comma, x equals 0?
Yep, that'd be perfectly fine. Instead of writing at, if you put a comma with the location, that would be fine. Quick question. With this in mind, if I were to ask you to find f of 3, how would you do that? Yes, sir.
Just use 3 for the x where it has it.
Yes, we're going to substitute in 3 for the x. When I've got more than one function rule, if that's all I'm looking at, I might not be sure exactly where to put it. That's where those domain restrictions come in. X equals 3 is over here. Which rule would I use to evaluate it then?
Y equals 2.
Yeah, y equals 2x plus 1. So I would do 2 times 3 plus 1, and I would get what? 7. What about if I asked you to find f of negative 7? Y equals 3. Because that is clearly over here, so it is governed by this rule. What about f of 0? 3. Because this is the output. It is not defined here. It is defined here. You guys ready to try another piecewise function? Yeah. All right. I'm skipping some of the ones that I have in the examples. So we're going to skip to example number 3. Start with, where should my fence go? Where is my domain restriction happening at? 1. At 1. So this right here, look for the commas. So at 1, I'm going to put my little dividing line. One thing I want to warn you guys about, just different textbooks, different notations. Sometimes it's just different software. When writing a piecewise function, a lot of times there will be a comma and then the domain restriction. Other pieces of software just put like a big gap in between the rule and the restriction. You won't see a comma, but you'll see white space. It's always going to be designated as being different from the rule. Which of these pieces lives over here on the left side? Absolute value of x lives on the left. So y equals absolute value of x. Does that one have any stretching, compressing, reflecting, shifting? It's just like the parent. What lives on the right side?
2x plus 1.
Y equals 2x plus 1. All right. Let's do that one first. Because when we did our linear function, I think it was even the exact same function. On the previous example, we had the y-axis in that yard. Here, normally I would use my y-intercept to help me graph this, but it doesn't extend back that far. Yes, sir?
Now you plug 1 into it because that's where we're starting off.
You can substitute 1 into it if you want to make a table, or if you want to, you don't have a calculator, so you'd have to do it off to the side. Another thing that you could do if you're sketching in pencil is that you could sketch in where it's going to hit the y-axis and then just go back in and erase that part. Where would it touch the y-axis at?
1
At 1, and then from there we would go
up to 1.
up to over 1. So I know I'd have these points here, but I can't have this one, so I can go back and erase that one out. Right here where it touches the fence, closed or open?
Close.
How do we decide?
Greater than or equal.
Greater than or equal to, right here in my domain restriction. And so then I would grab my straight edge to help me sketch in the rest of this line. On the other side, we have absolute value. You guys said there's no stretching, no reflecting, compressing, shifting. It looks just like the parent. Where's the vertex for the parent at? 0, 0. So right here. And then it looks like what shape from there? Looks like a V with a slope of positive 1 to the right and negative 1 to the left. So it's going to come over here, open or closed? Open there. The other direction, we're going to extend backwards so that I get this V shape. That's good enough. What is my domain on this? Negative infinity to positive infinity. We are heading to the left. It is defined for all values of x. To the right, it is defined for all values of x. And right at that domain restriction, it is defined.
Now, is there a chance where the Piecewise function will not be all of them?
Yes, there is. And I will try to make sure that we look at some examples like that, absolutely. What would the range be for this function?
0 to infinity.
0 to infinity. I know around the infinity it's got to be a parenthesis. What about with the 0? Bracket. Why is it a bracket?
Because it's
The dot is filled.
Yep. Right down here, the lowest it ever goes. That is a defined value. It's not an open circle, it's a closed circle there. Do we have any discontinuities here? We have a jump discontinuity. So you would say a jump at what? At x equals 1. I like using that little at symbol, the ampersand. Or you can put a comma and give me the location, that's fine. I just need to know where on the domain this discontinuity is falling. I want you guys to find the following values for me. Find f of negative 2, f of 0, and f of 7. What is f of negative 2? 2. What is f of 0? 0. What is f of 7? I'm sorry, how much? 15. Thank you. I just couldn't hear. Nice work. If all I gave you was the function rules, how would you decide which one you're using?
You'd be able to just plug it into.
Yep. We're not going to plug it into both of them. You have to look at that domain restriction to determine where you're going with it. Negative 2 is less than 1, so I put it in here. 0 is less than 1, so I put it in here. 7 is clearly greater than 1, so I only put it in here. We would not substitute it into both of them because it is not defined for both domains. All right. Let's do one with 3 parts. Let's do this guy. Haha. This guy just straight up looks evil. What are the domain restrictions?
Negative 1.
-1.
2 and negative 1.
2 and -1. Okay, so -1 is going to be a dividing line between these. And 2 is going to be the other dividing line. So I have 3 restrictions, but I only end up with 2 fences. That's going to separate my graph into 3 parts. Yes, it is that weird one. So I'm really hoping you guys watch the video, or else that last one's not going to make any sense.
I don't like that weird one.
All right, so there's my domain restrictions. I'm going to come over here and put them on my graph. I know I need one at -1. I know I need one at +2. Those are the only integers, the only values that I was given when I looked at those domain restrictions. Which of these functions occupies the leftmost side? X squared plus 1. Which function occupies this tiny little middle section? 2x minus 3. And the rightmost part? That is our step, our greatest integer function. So y equals the greatest integer of x. All right. Let's start on the left. We'll move our way to the right. On the left, what kind of a shape are we going to be graphing? A parabola. How is this parabola going to be different from the parent parabola? It's been shifted up 1, but other than that, it looks exactly like the parent. I'm going to sketch this in and then erase the parts that go into the wrong yard. Since I don't have a calculator, I can either make a table, but I have to do it all by hand, or I can sketch in what I know about the parent and just erase him where he doesn't belong. So the parent, what does the parent look like? 0, 0 is my vertex, and then where would it go from there?
Up 1 over 1.
Up 1 over 1.
And then up 3. I did that before.
Yep. So we're going to go, it's going to have a point at 1, 1. It's going to have a point at 2, 4. And then that would be reflected over here as well, right? Again, I'm just sketching the parent. I would not put this on my page because this is not where it ends up. That's the parent. How did you tell me this one was different from the parent again?
It's up 1.
It is up 1 from here.
Go up 1.
Every point would need to shift up 1. So like this. That is not where this thing lives, is it? I've just drawn this all across pieces of the graph. Where is it supposed to stop at?
The middle.
Yeah. This dividing line right here. So I need to erase this part out. I sketched it in there so that I could see where it's going to fall, but it is not in the correct yard here. So I need to erase it back to here. Is that correct? What's wrong? Needs to be an open circle right here, because it is not defined there. We did not have the or equal to on that. So I used what I know about the parent. I shifted the parent up 1. I sketched it lightly, and then I erased it from where it didn't belong. Again, if you want to make tables for this, that is fine. I'm not going to count that wrong. We just don't get calculators. So I'm trying to talk about multiple different ways or multiple approaches to this. In the middle, what kind of a shape are we doing? A line. What do you know about that line? Y-intercept at -3. I like it. The y-axis is right here where he lives. What is our slope? 2. So I go up 2, right 1. When I go up 2, right 1, I hit a fence. Do I do an open circle or a filled-in circle here? Open on the first fence.
And closed on the fence down below.
Yeah. Closed back here on -1 because that's where we had the or equal to. So here it's closed, here it's open. And now we're over at our step function, our greatest integer function. The best way I have been able to understand why a greatest integer function, which seems to indicate that I should round up, actually means to round down. I think about this like ages. Unless you're very, very young, nobody at this school, if I ask, how old are you? They go, I'm 16 years, 9 months, and 3 days. Most people will just say, I'm 16. Or I'm 17. Until you actually arrive at that next birthday, you don't claim that age. At least nobody would legally recognize you as that age. Even if you're 17 years, 364 and 3/4 days old, you are not 18 yet. It's not until that day arrives. That's the way my greatest integer function works. So I'm over here on this side. I know it's going to look like steps. Because it is the parent, I know each step is going to be 1 unit wide. I need to figure out where they're falling. Yep. So at an x value of 2, what is the greatest integer if I have an input of 2? 2. Whole numbers are what they are. Is this going to be open or filled in? Closed. We had the or equal to right here. And on the greatest integer function, it is closed on the left and open on the right. This is going to extend over, and I'm going to have an open circle here. Everything under a value of 3, everything under 3 years old, they're still the 2-year-old. Does that make sense? Okay. With an x value of 3, what would my output be? How high are we going? 3. Closed right here. Open on the right. And each step after that is going to be 1 higher and 1 unit wide. Until I hit the edge of my graph. What is our domain? Negative infinity to positive infinity. On the left side, I see I've got this arrow. It is tipping out to the left. This is defined for all negative values of x. Right here on this dividing line, it is defined. In between, it's defined. Here it's defined, and my step function is defined for all values of x, and there's nothing to indicate that it ever actually stops.
I have a question.
Yes.
So on a step function, and let's say that if the 2 was closed for the second piecewise.
For this?
Yeah, if that one was closed, would the other step function have to start at open or?
Yes, it would. Guys, did you just hear Erlen's question? Because it was fantastic. Erlen said, if this one in here, if we'd had less than or equal to, less than or equal to, so that it was closed on both sides, even though a step function normally goes closed, open, closed, open, closed, open, if it was closed on both of these because of my domain restriction, it would have to start with an open, open, and then closed, open, closed, open. I cannot have 2 filled in dots for the same x value. That was a fantastic question. Thank you so much.
Wait, why would it be open, closed, open, closed, open, closed?
On your 3rd birthday, how old are you? 3. 3 days later, how old are you? Still 3. 6 months later, how old are you? Still 3. The day before your birthday, how old are you? Still 3. When it actually turns your 4th birthday, that's when you jump up to the next stage. So that's why it starts off closed, it extends over, and it's an open dot when you hit that next integer, because that's where you make the jump to the next stage. All right. What is our range on this function?
-5.
-5. I like that. Bracket or parenthesis around the -5? Bracket.
And then infinity.
Ooh, this one gets sticky. So -5, yes. We are defined for outputs for y values all the way up until here, right?
Alright.
And then I've got an open circle there, so we get up to a height of 1. And it's open, so I need a parenthesis.
And then 2.
And then 2, so we've got this union. Closed or open at 2?
Closed.
Closed. Why?
Because the step function.
It is defined right here. So there is an output of 2. What about after that? Infinity. Over here, I can get every other y value, all the decimals and fractions in between.
No, the jump is gonna, the discontinuity is gonna be a lot.
Do we have any discontinuities other than jump going on here?
No.
No. So we have a bunch of jump discontinuities. Where is the first jump discontinuity you see? X equals -1. That's this guy right here. I have another jump discontinuity where?
2.
X equals 2, 3, 4, on and on and on and on after that. For my step function, I'm going to indicate that it's going up by integers, but obviously I cannot write every single one. So for my step function, I'm going to start that pattern and then leave it to the reader to understand that it goes every integer after that. Yes, Anthony?
If the parabola wasn't there, how would you write the range?
I'm sorry, one more time?
If the parabola wasn't there, how would you write the range?
If the parabola was opening down,
No, like, actually, yeah. Like, it would just be, I'm calling it right call.
I'm trying to make sure that I'm following here. So if I had,
Like, if it wasn't infinity because of the parabola, how would you write the
so like if it wasn't here at all,
Yeah.
so then my range would go from -5 to 1,
And then 1.
and then it would be curly brackets, integers after that. And I would list them out, and I would do it a lot like this. I'll see if we can't look at an example that's exactly like that to answer your question more specifically. Alrighty. What time is it? Cool. Let's do this one.
Oh, right. Oh, you get it,
How many fences are we going to need?
Third. No.
I'll wait until the opinions settle. What do we think? So I need one here. I'm looking for those commas.
3, 2, and 4.
Yep. So we're going to have 3 fences total. Here are my domain restrictions. I need a fence at -1. So back here. I need a fence at 2. And then I also need a fence where?
4.
At 4. No lies detected. Is there a function for each yard?
No.
No.
There's not a function between the 2 and the 4 yards.
There is not a function between the 2 and the 4, so this space will be empty.
They're having construction there.
There's a house going in. It's not in yet.
Yeah, they're working on it.
Who lives over here on the left? Step function +2, right? So the greatest integer of x +2. In this little tiny yard right here, who lives there?
X minus 1 squared plus 1.
X - 1 squared + 1 lives here. Whew. And to the far right, who's over there? 2x - 3. Where do you guys want to start? I heard step function first, so I'm okay. So does it matter where you start when you're graphing this? You can start with any of these individual pieces. It's up to you. I heard step function first, so let's start there. So we've got the greatest integer of x, but then I'm going to take wherever that would be on the graph, and I'm going to shift it up 2. What is the greatest integer of -10? -10. So it would be here, but then I do a +2 on it. So I shift it up 2 from there. So it's going to be closed and then open here. Once I've made that initial shift up, every other step after that is just one above it. Open when we hit the fence over here. Right. Let's do that parabola. That is the parent parabola that has been shifted how? Right 1 and up 1. Any stretching or compressing or reflecting? So the vertex is going to be right here at 1, 1, because it's gone right 1 and up 1. And then I know that it would look like this from here. I've got some dots on there that aren't going to stay, but I'm just kind of sketching in my guidelines for this parabola. Like I know that it can't stay over here. Should this be filled in or open? That one should be filled in. What about the other one? Filled in. Cool. So then I get this parabola shape in here. We leave this middle spot empty because it is not defined at all between 2 and 4. And then I have my line over here. We don't start until 4. If I put 4 in here for x, what kind of output does it give me? 5. So open or filled in here? Open. And then from there I have a slope of what? 2. Apparently I was feeling very creative with the linear functions when I was writing this.
Yeah, you like your 2x.
2x minus 3, 2x plus 1, it works.
You like your 2.
All right, let's do domain range discontinuities for this guy, and we will call that a day. Is my domain negative infinity to positive infinity? No. Why not?
Because of that little empty gap.
Because of that empty gap in there. Can we extend to negative infinity?
Yeah.
Yes. Negative infinity up until what?
2.
Up until 2, and then a square bracket because I got a filled in dot there. And then we've got this gap, so it's not defined between 2 and 4, so I need a union. 4 to infinity, parenthesis or bracket around the 4? Parenthesis. All right, for the range.
You would have to do curly brackets for your first.
Curly brackets for the first bit, so dot, dot, dot. And then I'm going to list several of these values so that my reader understands. I do need to state the last time that it's just a whole number. So,
-8, negative
yeah.
7, -6.
So you could do -8, -7, and then I could have dot, dot, dot. -2, -1, 0. When I have the curly brackets, that tells me that it's just those values. It's not the values in between. So my output is just -8, just -7, just -6. After this point, where does it pick up again?
All the way up.
At 1, so union 1, bracket or parenthesis? Bracket. Until when?
Infinity.
Infinity. I can get this high on my parabola, and then this takes me the rest of the way. We're going to start with a bell work that is a piecewise function tomorrow for you guys to practice with.
We do the discontinuities for this one.
Yes, we'll do the discontinuities for this as well.
So why can't, for the range, why can't you just say it's negative infinity if it goes down forever?
It goes down forever, but there's no value that I could substitute into any of these with these domain restrictions where I could get like -7.5. So I can't ever get an output that's right here. It's only these whole number values.
Oh, I see.